Welcome to Build with Nas. My name is Nas. I am the author of the Rebel Open Core repo on GitHub, which is a monorepo that contains a set of text user interface crates for Rust. I'm also the author of Developer Life. And in today's live coding video, I am going to go over TLS, Transport Layer Security. So in this video, we're going to implement a client and a server application in Rust using rustls, and we're also going to be using CFSSL in order to generate a bunch of self-signed certificates. So the bulk of the video is going to be configuring these certificates, generating them with CFSSL, and then loading them into our Rust program using rustls. And then the actual TCP protocol is going to be minimal. It's going to be a very simple cat application where the client will write some bytes. It'll be displayed and standard out on the server. The server will write some bytes. It'll be displayed on standard out on the client. And that's the end of it. It's just to basically have something to send back and forth over a secure channel. But the key and the bulk of the video is going to be configuring self-signed certificates, and then loading them into rustls, and then writing the Rust code to actually then establish a secure connection between the client and the server. So with that, let's get started. Since there's a lot of configuration steps, I actually created a repo with a lot of what these steps need to be in this Rust Scratch project that I have on GitHub. This is a collection of a bunch of these sort of test learning projects that I end up turning into videos. Anything that kind of graduates from this probably ends up in the Rebel core, the Rebel code base. This is the Rebel Open Core repo I was mentioning earlier with the text user interface library crates. The first thing, so let's take a step back and talk about what TLS is, or like transport layer security. So the idea with TLS is that it's essentially the backbone of, I guess, web security. Anytime you've used HTTPS, you're using TLS. And so what we want to do in Rust is actually now use that mechanism in our application. So TLS, and you can read all about it in this repo, but I'll just give a quick primer before we get into it. So it's a cryptographic protocol designed to provide secure communications over computers' networks. You have the client and the server, and then the communications between them are secured. We're going to be using something called self-signed certificates. So that's a little bit different than like what you're doing when you use HTTPS to connect to, let's say, Google or Amazon. Those are not self-signed certificates. You might have heard of Let's Encrypt. That allows you to generate not self-signed certificates, but certificates that are signed by a certificate authority, which is publicly available by a lot of computers on the internet. So we're not going to be using that. We're just going to be using self-signed certificates. Although you can, based on what you learn from this, you can also use Let's Encrypt certificates. It actually makes some steps a little bit easier and other steps about the same. What this transport layer security does is it guarantees that the data is encrypted, so the intended recipient can read it. So on the server side, we're going to have a certificate authority, where we'll generate a certificate. I think it's X509 certificate, if I'm not mistaken. Pretty sure it's X509. Yeah. So we're going to generate an X509 certificate for the certificate authority, which we're going to establish as the root. This is something that, because it's self-signed, we have to do this. If you use Let's Encrypt, you don't have to do this. You're just using certificate authorities that are available by computers on the internet, publicly available. Mozilla has one of these. So essentially, like the data between the client and the server, we're going to ensure that it's encrypted, so the intended recipient can read it. And we're going to ensure the intended recipient can read it in our case because we're going to generate a certificate for the certificate authority with which we're going to sign another certificate for our server code. and that server code will also have a private key. So then we're going to have client code, which actually then loads the certificate authority certificate. So the client code will have the certificate of the certificate authority. The server will have a certificate signed by that authority with a private key, and we're going to bake those files, the key files and the certificates, the X509 and the RSA keys. We're going to actually put them inside the binary of our Rust code. So the client and the server code will actually have those files embedded inside of the binary. So that will ensure that you can't have for a particular certificate on the server signed with a particular certificate for the certificate authority. Since the certificate authority information is baked into the client code itself, they're kind of like bound at the hip, so to speak. So if I change, let's say, a bunch of this configuration stuff on the server code, and I run the old binary from my target release or target debug folder in Rust, it won't work because the certificates won't match up. So that's what this means. You'll see this in action in a moment. So integrity, the data cannot be altered without detection. There's a handshake that happens between the client and the server. And authentication, the identities of the parties involved can be verified. So so we'll go over all of this. So the key here is that there's two types of encryption involved. One is symmetric encryption, the other one is asymmetric encryption. So the TLDR is that the drawbacks of asymmetric encryption is that it's slow and it's not suitable for encrypting large amounts of data. That's the downside. So if we use asymmetric encryption to encrypt all our payloads back and forth, security is achieved, but performance takes a hit. Symmetric encryption, on the other hand, is fast. But the drawback is that ahead of time, both parties need to know the key that will be used to decrypt, whereas with asymmetric encryption, that is not a requirement. So symmetric encryption is no good at exchanging keys between clients and servers, but it's really good at, let's say, encrypting the payloads, whereas asymmetric encryption is really good at having essentially two computers come up and using private key encryption, public-private pairs, public-private key pairs to actually do the encryption so that the actual key is not transmitted in plain text or anything between the client and the server. So yeah, that's the TLDR. But yeah, please, this is not meant to be a deep dive of TLS. You should read that if you have any interest in it using other sources, but this is the sort of the bare minimum that's necessary to build this project. So yeah, so this is kind of like where, I don't want to say it this way, but this is where as Rust programmers, like, we actually care, is that these are the touch points between TLS and our Rust code, is that the client program that we're writing needs to have access to the certificate authority certificate because we are self-signing. The server code needs to have access to both the server certificate, which is signed using the certificate authority certificate, and a private key. So we need both of this information. So we need two pieces of information for the server code. We need one piece of information for the client code. And these are three, in aggregate, these are three different pieces of information. And we're going to be generating a whole bunch of these files using CFSSL. It's like 6 files we generate, and we're going to be using only 3 of them in our Rust code. But we need all 6 of them for, it's actually more than, so 6 files are generated, but they're generated from 3 files. And I'll walk through all of that in gory detail, which is pretty much mostly what this video is about. So an overview of how TLS works is that there's a handshake between the client and the server. So basically, you create a TCP connection between a client and the server. You tell the client, connect to localhost 8080. The server listens on that port, accepts the connection, and you have a TCP stream between them. So then you have to upgrade that TCP stream to a secure stream. So that's this TLSConnector thing and TLSAcceptor thing that we're going to look at. So essentially what happens during this is called a handshake. So the client and the server agree on the TLS version and cipher to use. The server presents its digital certificate, which contains its public key. That's how the client code will actually then encrypt things to send it. The client verifies the server certificate against the certificate authority. That's why we need to bake the certificate authority credentials into the binary of the client code. And the client generates random session keys. Oh, I'm sorry. The public key is not meant for general purpose. It's not for encrypting payloads. It's just during the handshake process. For the payloads, this is what will happen. So the client generates a random session key, encrypts it with the server's public key, and sends it to the server. So once the server receives the encrypted session key, it decrypts it using its private key. Both parties now have the same session key, which is used for symmetric encryption. So the payloads are going to be encrypted using that key. So that's the handshake. The good news is you don't have to write any of this. You just use the rustls library, and it does, quote unquote, does all this for you, which is pretty awesome. Once the handshake is complete and the session has been established, then all data sent between the client and the server is encrypted using the session key, ensuring confidentiality and integrity. So that's awesome. So, and we'll see in the Rust code like what that looks like. Essentially, you do what you normally do, but before you actually split the TcpStream to get the reader and the writer half in Tokio, let's say, you have to upgrade your TcpStream to some other thing. It's like TLSStream or something like that. And that's essentially the bulk of the difference between the client and the server code. The rest of it is mostly generating these files that are necessary to actually make TLS do what you want it to do. So a lot of configuration, not a whole lot of writing code. So that was TLS. So now let's take a look at briefly the difference between rustls and native-tls. So in this live coding video, I'm going to use rustls. So there's two ways of dealing with TLS in Rust. You can use rustls, or you can use native-tls. So native-tls is not Rust. It's your native platform's TLS implementation. So it uses OpenSSL, let's say, on Unix-like operating systems, and something called schannel on Windows, whatever that is. But the Rust crate is just a shim that allows you to essentially get a handle on, platform like native code that is running in your operating system. I didn't choose that. I chose rustls, which is a pure Rust implementation. So regardless of what operating system you have, your TLS layer is being delivered to you in pure Rust code. There's pros and cons. So let's say your OS, if you use the native implementation, when your OS, let's say on Ubuntu, you do sudo apt update or upgrade or whatever, sudo apt upgrade, and then you get a new OpenSSL version, then your Rust program, because it's just linking to binaries that are already in your operating system, will also get the update. Whereas in rustls, if you don't update the rustls version in your cargo toml, then you will potentially be stuck at an older version of TLS implementation. So that's the sort of the pros and cons between the two. So after this, like most of this video is going to be how to configure TLS. So we're going to create because we're using self-signed certificates and not something like Let's Encrypt, we're going to have to create our own certificate authority. We're going to have to create our own server certificate, and we're going to have to generate some keys for both of them. So let me create a new project, and then let's get started with the coding portion. One thing I want to mention before we create a new project is that we're going to be using this tool from Cloudflare called CFSSL, which makes it relatively straightforward as straightforward as it can be, to create those certificate authority certificates and the keys and the server certificate and private keys and all the things that we'll need. And I'll put a link to this in the description, and it's also linked in this README for this repo, which will also be in the description of the video. But go through this, and it essentially covers in great amounts of detail, like stuff we're going to be skimming over because I don't want to go over every single command and its options and what it does. And then if you want more information about this, you can also read this GitHub post. So it's all in the README actually for this repo. So yeah, and CFSSL is just we could use OpenSSL binary and do all this stuff, but I think CFSSL makes it much easier. And to make it even simpler, I've created some scripts that we're going to be using to actually generate them, because it's a bit tedious to kind of go through and figure out what all the different options are. So with that, let us make a new project called TLS, and we're going to open this in VS Code. There we go. So we have, let's see, zoom in. Okay, so oh, actually there's no, should probably create a cargo init. Let's make a bin. Actually, we're gonna have 3 binaries, one for the server, one for the client, and one to verify the certificates, but let's just start with one. So let us fill out these dependencies before proceeding further. I'm just going to copy and paste a bunch of these dependencies because it's not that interesting. So here you will see these are all the dependencies that are required for rustls. And we'll need Tokio, we'll need net for error handling, cross term for displaying colorful messages to standard out, and a bunch of the Rebel TUI crates for some awesome features that you can get from them, and futures util, which is actually related to this one. It's kind of like that, async streams. Okay, so let's see, what do we do next? So now that, oh, actually we also need some entries for this thing, the 3 binaries. So we're actually gonna have 3 binaries, something called gen cert. Actually, it's not really gen cert, it's like check cert. Yeah, check cert. And these are Rust binaries. And then we have the server binary and the client binary. So let us, I'm gonna delete the main file. I mean, the main RS we won't need it. So let's make a new bin folder, and inside of that we're gonna make, let's see, we're gonna make check cert rs, and actually this one should be check. So once the scripts generate the certificates, we're gonna actually load them up just so we can parse the certificates and stuff like that before writing the client and the server code. So now we have client rs and we have server. What happened there? And then we have, let's see, server rs. So here we'll say fn main, say, this is actually a to-do, so we'll do this, and then the client wants same thing, and for the server, same thing. Perfect. So we have our client and server and check cert binaries all stubbed out, and let's see if we can cargo run client. This should just print a just a message to standard out. I just want to make sure that all the dependencies came through and everything is compiling before we get too far. So we can do client, we can do I think it is check cert, and finally server. Okay, great. So far so good. So we can say git add -a. Actually, let's just do this. Say git, let's say initial commit. Perfect. Okay, so now what we want to do is, because we have to use CFSSL to generate a bunch of certificates. In order to generate those certificates, we need a bunch of JSON files to configure them. Let's do that first. So one thing I'm going to do is make a new folder actually, I'm going to do like this, make dir, because we're going to need certificates, and inside of certificates, what do we have? I think we need config. Yeah, so I think, yeah, okay. So basically we have the certificates folder inside of which we have a config folder. So inside of this config folder, we're gonna create 3 files. One is for the certificate authority because we're doing self-signed certificates. So we'll do ca config JSON. And where these came from is actually in the CFSSL, there's defaults. You can actually do this thing called print defaults for CFSSL, and it basically, actually, let's see if we can find it, defaults. Yeah, so if you do like CFSSL print defaults config, why not just do it? Let me put it here. Oops, where's the terminal? Here we go. So here, let's say we do, where are we? So we do TLS. So we go to our certs folder. So let's say here we do, so CFSSL, as you can see, it's not, that binary is not on our system. So you could either get the binaries directly, you can download them, or you can get them from the, the releases page on this GitHub repo. So for now, what I'm going to do is, because we don't have the binaries, I can't run this command. But what I will do is I will get the first script to get the binaries. So let's start with that. So let me just go ahead and delete these config files real quick. But before that, the first thing we're going to do is, here's the script, and I'm just going to copy and paste this here because otherwise this video would take way too long. And this isn't really about writing for scripts, and this is yeah, here we go. So we have let's see, is this maybe this is in the wrong folder. Oh yeah, it's in the wrong folder. Okay, now it's in the right folder. Okay, so let's make it executable. And so basically what this the script does is that it's fish script. So if you're not used to fish, this is in bash. If you use bash or Z shell or new shell, this is a little bit strange. So here we have essentially a program script that what it does is that it'll make a bin folder, and inside of that bin folder, it will get the latest version of CFSSL from Cloudflare's repo. So it gets it from Cloudflare CFSSL. Cloudflare is the organization, the repo is CFSSL. It goes and it finds the latest release tag, and then it goes and gets the binary. So basically this. So you run it, it goes downloading binaries, and then these are the, there you go. It basically now, we have a binary folder that it created, and inside of the binary folder we have CFSSL and CFSSL JSON. So that's step 1. And we were going to look at those defaults. And so here we can say CFSSL print defaults for certificate signing request. This is something that we will use. We can also print defaults for config, server config. So this is something that we're going to use as well. So one is for the certificate authority, this one, because we're doing self-signed certificates, and this one is for the server config, because we're going to make a certificate authority, we're going to make a server certificate, we're going to sign with that certificate authority. So it's a lot of words. A lot of words with the word certificate in it. Okay, so that's step 1. So now let's look at the config files that we were making. So we'll need 3 of them. So the first one is ca config JSON. This is for our certificate authority. This is like the main the root, because we're self-signing. Then we're going to need a certificate signing request, and then we will need a server certificate. So let's start with the first one, ca config. So let's see, here's the sample ca config JSON. So it says something along the lines of, and this README has copious details on what this does, what all the key value pairs at each one of these levels, like what this node means, what that node means, what that, and so on. And then the README also has a whole bunch of information on like what these files do and where they fit in the scheme of TLS and so on. But we are going to go through each one because we're going to be generating our certificates based on this declarative. You can think of it as a declarative, some DSL that we're providing some information, and it's going to take this configuration and generate us a bunch of certificates based on this data. So one of the key things to note here is we are creating a profile named server, and the expiration for that is 10 years. So we don't want to keep making these certificates, because if you use like Let's Encrypt, it expires in 3 months, even though you can renew it automatically, but still. This is just for like a toy project to play with. So for that, you can put whatever number you want in here. 10 years is probably a bit much. And then these are usages, like we're going to be using it for server authentication, key encipherment, and signing. So this is stuff that kind of comes out of the box with this. So those are the defaults, and the key here is this one. This name is important. So if we call a server rather than foobar, we're going to have to continue using the word server or foobar, whatever we name this, throughout these 3 configuration files. So it's important what we name the profile. So the next one we'll look at is the actually let's look at the which one is this? The certificate signing authority, the CSR. The CSR is the certificate signing request. So here we're actually naming our certificate authority to CA, but we can name this to whatever. But again, whatever we name it, we should remember what that is, because we'll need it in the rest of the scripts. The algorithm, you could put whatever algorithm you want here. I chose RSA 2048 is good. You can make it like any multiple of 1024, so you can make it bigger if you want. But whatever this is the key. Like we're gonna be there, like we're saying, use RSA algorithm for the encryption with a key size of 2048. That's for the certificate authority. Then for the server, we're gonna have to do something similar. So here's the server, and again we have that the algorithm and the size of the key. That's this. It just so happens the same, but they don't have to be. The important thing here is that we named the server, and this name server kind of carries through with this profile. And this is super duper important from the Rust side of things. Whatever word you put in here, whether it's localhost or, oh, this is already incorrect. I updated it. Oh, oops. What is this called? Server JSON. Yeah, so this one is not that. It is, where did it go? This one. Yeah, so this one is going to be, let's say, rebel.com or localhost. So whatever this name is, when we make the connection, the client-side connection on the Rust code, we have to get this name right. It has to match up with whatever is in here. So for example, and there's a struct called server name, which is part of the Rust TLS, the PKI types. I'll go over those here. I have it open in a tab, but this the format of this is something that is either an IP address or a DNS name. So it has to be something parsable as a DNS name or an IP address. So it could be like, you could put like, 10.0.0.1, whatever you want. You could put 127.0.0.1 for loopback address. It doesn't matter. That's an valid IP address which can be parsed, which is cool. Or something that looks like a domain, name. A domain name that can be parsed. So I just wanted to point it out. So and these, it doesn't really matter. I just put a bunch of stuff in here, but you can put whatever you want in these in this metadata. This will actually show up in the certificate, but we're not using it in any meaningful way. So, so then all of these files will be used by the CFSSL gen cert command. and they will end up generating 6 files. So in order to simplify things, I'm just going to run this script called gencerts, which I've created, because the commands are just, it's not user-friendly or intuitive. So here's our gencerts fish, and I think I have to mark that executable. Where are we? I think it's, oh yeah, so, okay, so now it's marked executable. So here, I'll just walk through this like without going too far into the weeds. But here, there's really like there's a bunch of setup that happens, and this setup is to make sure that all the information we provided in our JSON files flows through correctly into this script. So we're saying that we have this configuration file called CACSR, the certificate signing request. We have a certificate authority configuration file. And by the way, these were generated using defaults. So something called CFSSL print defaults config was used to make the CA config, and this was used to make the server JSON. So that's why if you look, this one looks different than these two, which look similar. That's because these are both certificate signing requests, and this one is certificate authority configuration. So if we go back to our gencerts, so here we say, okay, here's all the config files that we're going to be using. So CACSR, CA config, server JSON. We made these three config files here. These three, and then what it's saying is that, okay, make sure to get the names right. So I use CA for my certificate authority. Where is it? This one. And I use server for my server certificate. And this is just make, oh wow, the highlights go away when you navigate away from the file. The joys of using Insider Edition. So yeah, that's what these are. And these kind of flow through and end up generating a certain like files like ca.pem, ca.key.pem, and server.pem. So these are just things that we're passing into the CFSSL gensert command, and you can study this script in far greater detail to understand the nitty-gritty of what the CFSSL command does, the gensert option does, or the gensert command. The CFSSL tool takes a command, and the command is gensert. So for example, and then so you can go through this and kind of match up, what all these configurations do. But essentially here we're generating the certificate authority stuff, and here we're generating a certificate that is signed by the certificate authority. So the certificate authority says that this server certificate is good. That's essentially what's happening here, and all of these config files kind of work together. And when you run this, let me run this. Let's see, real path. This script is just to make it easier. Everything is parameterized. There's variables for everything. It's just, otherwise it was very difficult to sort of understand what is the impact of changing like one of the arguments here. And how does it match up with something like this? So this script kind of makes it as sort of transparent as possible, not opaque. Okay, so now we ran get CFSSL. Even if we hadn't, gensert actually ends up calling CFSSL. So it's very smart. So, and then it uses CFSSL, puts it in the binary folder, and then it uses these JSON files and these options, to actually generate the 6 files that we're going to see. So here we can say gencerts, and what it has done is that, let me see what it did. So let's make this smaller. So here we have, if you look in the generated folder, there's 6 files, and these 6 files correspond to or are derived from these 3 JSON files. So there's a let's see. Oh, and actually the script then goes, once these files are generated, and actually verifies them using the OpenSSL tool. So it checks to see that the server certificate that was generated is actually correctly signed by the certificate authority, and then it looks inside the certificate authority, and you can actually see what kind of information we're looking for here. So like one of the things is CA true. This is very important. So if you look in here, where is this? Let's see, certificate authority, is it true or false? So this one, certificate authority, is false, because this is we're looking at a dump of the server certificate, not the certificate authority certificate. So let us go see. So basically we could do it like this. This is, instead of sort of, there's no suspense really. It's like you say OpenSSL x509 no out text in, and then you say what the file is, and it will give you a dump of that. So in our case, this ca.pem is actually the certificate of the certificate authority. So here we'll know that that's the case because CA is true. And then remember we said the RSA encryption to 2048-bit key, that's what's in here. All the information we put about in the JSON files about like US, Texas, Austin, that's in here. And the name, remember, the CN equals CA, that's here too. So it's, now we can see how the stuff that we put in our JSON files is actually showing up here. And then look at this, the issuer is the certificate authority. So this is the certificate authority itself issued, hence self-signed certificate. So, okay, so now we can go look at the server one, which is pretty much the same command, except that we do server.pem. And here we can see right away, this is not a certificate authority certificate because it won't, this is set to false. And same thing, RSA 2048 encryption, the same information for here. And here we say CN is server, not CA. So we know this is the certificate. This is not the certificate authority certificate. This is the server certificate, which is issued by CA, which is our certificate authority. So that's the certificate we just saw earlier. Whew. So there you go. That essentially, and there's the 10 years, it's in here somewhere. I think it's, where is this? It's in here somewhere, the expiration date. But anyway, and then, oh, this is important too, the subject alternative name. This is the thing that the REST client-side code will use to actually create a server name struct that it must match with what's in the certificate. So regardless of the IP address and host name is, the IP address, host name, port, whatever that we're connecting to, this subject alternative name must match up. So I should probably put that in this documentation. Yes, this would be nice to put that in there. If it's not there already. I do not think so. Okay, so I will update this and put that there. Actually, it's kind of here, but this is this needs to be elaborated further. It actually is, but it doesn't really say, like, you know, the client side is going to be, the client side code is going to be using this, and this has to match up with the client side code. And finally, we can actually run a verification to make sure that our server certificate is valid when, and it's certified or issued by the our certificate authority, and that's this command. And it just says okay. So if you looked at the gen certs script at the very end, it dumps the server.pem to the output, and it also checks to see that the server is certificate is signed by the certificate authority. One thing actually I should add here for when we're verifying, let's see, in the display status function, I think it should also display the CA, this one, ca.pem file, because why not? So essentially this is the certificate authority, this is a server, and this is verifying that the server is signed by the certificate authority. So now if we do gen certs, yeah, there you go. It should display all that information. Cool. Okay, so that is done. Actually, I probably want to upgrade this. Actually, I'm going to update the README in this this README to make it clear that this is super important. The Rust client code uses this to and server name to make a TLS connection. So let me save this real quick, and that should update the this README. Oops. Or was it? I think it was DNS localhost. Can't type. There we go. So yeah, perfect. And yeah, so okay, DNS IP address, perfect. So this, okay, in server JSON, I think also the server JSON, there's probably a whole bunch of information I put in the let's see, I think I've documented, yeah, like right here. So if you look at server JSON, there's even more documentation, like copious documentation saying that the server's name, you know, make sure to remember what you put in there and make sure to remember that it's correct. So, because otherwise, you know, you have to go and debug your certificates, which it's difficult enough to get it right the first time, much less go and debug it. So, and that's just for, you know, basic configuration stuff. So let us do this. We added a bunch of stuff, so we can say add scripts to generate certs. That's done. And actually generate certs too, not just add scripts, generate certs. Add scripts and generate them. Okay, so that's done. And so now finally now that we have the TLS stuff out of the way, the next step is to actually write Rust code to connect, to load up all this information. First, we're going to see how we can even access this TLS files from Rust. That's the first step. That's going to be this, not gencerts, checkcert program. That's what this is. And then after that, we're going to write the server-side and the client-side code, and then hopefully it will all come together and work. So the first thing we want to do is take all the files that we generated, which is the, so we had a bunch of config files, which we use CFSSL and had them generate these certificates, one for the certificate authority and one for the server. So in order to get started, like let's start with the, kind of build it up from the ground up. So in order for any of the TLS stuff to work, these files need to be loaded into the Rust binary. So let's start there. And so one thing we have is a, where is it? A binary, actually a Rust file called checkcert. So what this will do is that we're going to essentially write some functions in a different file. And we're going to use those functions to load these. We need 3 files loaded into this binary. The Rust binary target, and so one for the client and 2 for the server. So we're gonna do that now. So the first thing we need to do is we need to build a actually, what is this? You know what? Let's just do command line. Let's see. The first thing we need to do is in the source folder. We need to create a librs and a TLSRS. So let's do this. So in the source folder, we have librs, and in the librs, we are going to simply load the TLS module and re-export it, and whatever's in there. And then in the TLS module, okay, so here's where the fun begins. So what do we put in the TLS module? Let's see. I think the first thing we want to do is maybe load the correct files. So let's do this. Binary, pubmod binary data. And in this binary data module inside of TLSRS, we're going to create, let's say, for the client, kind of say client files, and we have server files. So I think the client files we have are, we have certificate authority, certificate, I think PEM file, yeah. And actually if we do file name, because it'll be nice to have this for like debug messages, so that's that. And then we can, that's just the name of the file for debug messages. It does, we haven't loaded any binary or bytes yet. So if we do, let's say ca.pem, and then this one will be actually U8, and we do certs. Actually, I don't think this is the right folder. It's red, so certs, we go up one from this folder, which gives us that folder, and then we go certs, which is correct. And then generated, there it is, ca.pem. Okay, so easy fix. So what this does is that this macro will just pull in whatever the contents of this file are and bake it into our binary. And this is just for debug messages, because I cannot put, like, for example, this macro will not allow the following. Like, I cannot say like something like, what is this? That's not, it has to be a string literal, so that's why these are awkwardly separated. So let's see, we have, okay, so on the server side, we need the server certificate, that is correct. We need, that is also correct, very nice, good job. Copilot. I have pigeons in my balcony. They're really adorable. They come to visit every morning. Okay, so let's see. What is this? Pubconst server. Yeah, this one will be server-key.pem, and then, yep, that's right. Okay, so these are the server files. These are the client files, these are the server files. Maybe if I write it like this, it'll be, yeah, maybe. Sure. Okay. So yeah. So we got like, so that's great. So now we've pulled in the binary data from the certificates that we've generated into this thing. But obviously now we have to turn that into, this is where rustls comes in. We're going to use rustls to transform these bytes into the appropriate structs that we need to move forwards. So let's take a look at the rustls crate, because these binary files are going to be converted into a bunch of structs in the next step. So I think, let's see, pulled up the rustls crate here. So there's actually two interesting ones. There's a PKI types. This is a crate that's related to the rustls one, and so is this one. So PKI types is actually has a lot of good stuff, like most of what we're going to be converting our these bytes for our files. They're going to get converted into these rustls PKI types. So I've actually already imported the rustls here. So these are the imports that you need. So one is rustls, then is tokio rustls, because we're using Tokio and rustls.pem file. So these are the imports that we will need. And then let's see. I think we'll need private key dir, because we have a private key. I think it's not in here. I think it's in this crate. Yeah, certificate dir. Yeah, I think it's this one. So let's do this. Duplicate private key dir. Yeah, that's it. So a dir encoded x509 private key, and so on. Oh, and there's also PEM encoded. I think ours is PEM encoded. Because, yeah, ours is PEM encoded. Okay. Interesting. So we go private key dir from PEM file. This can load several types of PEM encoded private key files. Okay. I wonder what the dir encoding and PEM encoding means. Let's ask duck.ai. Say PKI in the context of PKI. What is the difference between PEM and dir and encoding of keys? Public key infrastructure, privacy enhanced mail, and distinguished encoding rules are two different encoding formats used for representing cryptographic keys and certificates. PEM is base64 encoded. Okay. Dir is a binary encoding format. It does not include any headers or footers. PEM is base64 encoded. Dir is not human readable. Okay, so PEM looks like all our stuff is PEM encoded. Okay, cool. All right, so maybe it should be certificate PEM then. No, it's still certificate dir. Oh, okay. So apparently you can get a certificate dir from a PEM encoded file. So that's what we're gonna do. Okay, that makes sense. That clears up some confusion. So it all ends up as a private key dir or a private key, or sorry, certificate dir, regardless of whether it was PEM encoded or dir encoded. In our case, they're PEM encoded because if we look at these files, they're text. So there's a private key. Then there's the, where is this, server ca.pem certificate. Okay, so we got the certificates. That's cool. All right, so with that out of the way, let's create, now that we have the binary data module, we need, and I'm creating these, let's see, inner modules just to make the code easier to understand. Otherwise it'd be like too many functions at the top level, which is just not great for readability. So these are certificate ops because we're going to be using them to work with certificates. So this is the binary data. The binary data is going to be transformed by, yeah. Okay, so we're going to say, so we need, let's just start with the, let's see, should we do the server files first? Let's do, okay. So let's do this. We're gonna make two inner functions. So this is gonna be, let's say we're gonna say load key, because there's a key and there's a certificate. So either way, so we can say get, let's say certs from PEM data, because that's what we have, and the PEM data is actually, let's see, PEM data, did it do it correctly? Certificate, no, because our type is actually certificate dir. So let's see. Okay, so here's where all the imports are going to start happening, and we can do, okay, so vec of certificate dir, and then we're gonna read, this is right, I don't know why, let's see, reader, and then, okay, so this loads the PEM data, so let's say that we'll give it this constant, which is of type slice of U8, and then we'll say, hey, because yeah, we'll just say, given this certificate, or this certificate, go get me, it's a certificate chain that comes out of these bytes, and then we'll display that to in our application, in our binary, the check cert rs. So let's see. Okay, so just trying to keep all this. Okay, so we got certs that we return. It's an empty vec, and then here we go. So it's looping. Actually, I don't know what it's doing here. Let's do this. Say for item in, let's say, for item in, I think there's a, this is all wrong. There's actually a function called read1, because we only have one. Where is read1? Read1, is that here? No. rustls read1. In Rust, oh, the PEM file. That's right. That's why we had this this one. This is a different crate. It's a rustls PEM file. So let's put that here. Is that the correct zoom? Yes. Okay. So read1 rustls PEM file. It extracts and decodes and expect. Okay. So for item, you can use this function to build an iterator. So that thing. Okay, let's do this. So for an item in iter, sure. I think it's let's see, where did iter come from? Standard library iter. Yes, standard library iter. So let's do this. And then read1 will come from, let's say, rustls, okay, and then read1, I think this one we give it the reader. Yeah, mute reader, and then I think it's transpose or something. Transpose this one. Okay, and then push. Actually, no, because that's not really the right, it's not a certificate dir, so this is, we have to convert, actually, before we push something, we gotta do this, we gotta say match item, and that can be, actually, if we can just continue. So we're looking for something specific. We're looking for, let's see, item that is a PKCS1 key. Is that right? Item PKCS1 key. Yeah, that's it. And then the key is in there. And then what we want to do is we want to take certs and push, oops, nope, p private key dir, which is, yeah, I think this is right. Holy moly. It's not liking this because, oh, I messed it up. This is totally wrong. This is, it should be vec of certificate dir. And we have certs that we're going to return. Actually, let's call this return certs, or yeah, so return certs. So we're going to do item transpose, and then the match item. Oh, okay. This is going to be not a key. This is going to be a X509 certificate, and that is a cert, not a key. And we should just be able to say return certs push and the cert. Whew. Okay, is it happy with this? Yes, and then let's do this. And these are our imports above. All right. Wow, this took a bit of research actually. I had to do a bunch of research in this. This was not easy. Like to understand this read one function was like the key, and then there was some sample code here that I mean, it's not barely even sample code, but it gave me some clues as to how to decipher this. Okay. So here we have the dir encoded X509 format for certificates, and we loaded it from PEM encoded file. So that's the roughly what is happening here. So the PEM file is actually here, ca.pem for example. And then this will give us a backup certificate data. So let us do this. I think we should be able to just print this out and see what we get, because yeah, so let's say we have so let's say that's the function, and this is, notice this returns a vec of certificates. So let's say, okay, so let's say we want to do some error handling or something. So, and let's say we don't want to pass in the argument because because we know it's always going to be like for a certificate, it's going to be the certificate PEM file, or it's going to be the server, whatever, one of these two. So let's hard code this. So we can say, I want the server to load the server certificate chain, and I want that to give me, oops, what the heck just happened there? Me at result, and yeah, something along these lines. And why is it complaining? Oh yeah, static. Okay, so, and these are going to be static because this binary data is static. So let's see if this did it correctly. So the PEM file is so I'm saying server load server certificate, and I prefix of server because this is the server code that we're going to write, which is going to call this function. It could have just easily been called this, but I don't know. It seemed readable, a little bit more readable to keep all this, you know, from to keep it straight, basically. So what if there's it's empty? Then what? So we should probably have a situation. Let's say we can say, so if it is empty, then we can just say met bail, and otherwise we say else, and then we can just say okay it, and I think that should be it. And this I don't like typing this. I find it to be very unreadable. So in the rest, in my rebel, what is this called? The rebel core. This one, actually, the rebel core one is, let's see, where the heck is this? This one. Oh, why is this not DuckDuckGo? That's weird. What? I don't know. 1 second. Default search engine. Oh. Okay, so let's do this again. What is happening? I said default search engine is Chrome. Search engine. Okay, change DuckDuckGo. Set as default. Okay, maybe I need to close the tab. docsrs server core. What? I don't understand. Whatever. Okay, so here we have what the heck is this called? Okay, macro. There it is. Yeah, it's just a syntactic sugar, basically. So you can just say like okay, and then if you don't pass it in the arguments, it knows it's a unit type. If you pass it an argument, then it'll just okay whatever you give it. It'll replace it. The macro will expand to that. Okay, so I think we were in the certificate land. So now we have the server. We can load the certificate. That's fantastic. And then while we are loading certificates, let us load another one, which is the actually, what else do we load from this? I think we do when the client loads the certificate chain. I think we should do that as well. So we can say pub.fn. The reason I didn't put pub here is because I don't think anything outside of this module really needs this. And technically speaking, this could also be in the binary data. I mean, it's not, this wouldn't be out of place in a way. Super, but I mean, it's not really binary data because we're transforming the binary data into these Rust types. So I think that's what my thinking was. All right. So now let's make another one. So these are going to be pub fn client load certificate authority and then certificate chain. Hopefully hopefully this will do a good job. Let's see, is that right? So ca.pem file, that is correct. If it's empty, bail with ca.cert, that's actually really good. ca.certs, and we can just call this certs, and we can call this certs. So if search is empty, no certificate, no server, certificates found, and this is no ca certificates found. So these error messages are, this is what I was after. There we go. Okay, so that should work. So client load certificate chain, just to make sure. This is the client side code that's going to be calling this, and it's loading the ca.cert.pem file. And if you go in here, that's just ca.pem. And for the server side, when we load the certificate chain for the server, it's going to be essentially server.pem. So we've now covered, I mean, if you want to put it this way, we can say this is server.pem. And this one is ca.pem. So we've handled the ca.pem to X509 certificate, and this one is X. Sure, whatever. But actually, that's not whatever. That is correct. Okay, so they're encoded format for certificates, and yeah. Actually, it's not really dir encoded. It's actually PEM encoded. You know what? I'm just going to drop this. It's PEM encoded, but because of the crate, it's the name is certificate dir, even if we wanted to go after a PEM, a PEM file. So yeah, okay, that's slightly confusing, but there we go. So server.pem, gets converted here, and then let's see, server.pem and ca.pem. Perfect. So now that we have these, I think we can put this in check certs just to kind of check our work so far. So I think that what we can say is let's handle or not handle, let's say parse server.pem. I mean, I don't know if it's parse, it's whatever. Load server.pem certificate, exactly, and then load ca.pem. That's exactly right. So let's do this. So, and we know we have a function that we need to call, which is this one, TLS certificate ops, and then whatever server load. This is going to be on the, this is in server code, actually it's server rs, server rs in client. So maybe what we can do is do this. So we can say expected to be called in server rs, and this is expected to be called in client rs. Poof. Okay, this seems a bit overkill right now, but given how much stuff there is, this actually is it's good to kind of keep things straight, because there's actually one more file, which is the private key for the server that we have to accommodate, which will go in here. But for now, let's get the certificates working. So we can say let server, and it's not cert, it's actually a certificate chain. So it's going to be like, let's see, root cert store, no, it's 1 second, chain, I guess, chain, yeah, chain, and then let's see, cert store, yeah, let's keep the name chain. Okay, so we say server cert chain is, why is this not working? Oh, I see, this is TLS : that is a very long name. So, and typically we will not do unwrap, so then have this met result, and at the end just put an OK. And this again comes from rebel core or whatever. This one, nope, I put it the wrong one. Rebel core. Okay, I'm glad I checked that. Okay, so certificate chain, that's the certificate chain, essentially the server.pem file. That's one of the 3 files we're interested in. Server.pem, ca.pem, these are the 2 we're going to handle, and the next one we're going to handle the server key. So here we can say to do load, oops, wrong place, server-key.pem. Actually, I don't know if it's pkcs8. What is it? pkcs, maybe it is pkcs8. I guess we'll find out. All right, I think it's pkcs1. Now I am getting sidetracked. Let's see if it's pkcs1 or what. It is pkcs1, not pkcs8. All right. Yeah, okay, so where were we? All right. So here, it's a to-do for next, but for now, let us do this. So, and then we can just say print line server certificates, and because we want to be really fancy, this is a little trick we can use. This is why we basically this is the cross term stylize, so this way we'll see, you know, it'll be readable. Okay, and then so this dumps the server.pem, it loads it from bytes we generated using CFSSL, and then it's going to dump it to our terminal, and then we will do the same with the certificate authority certificate. So yep, and this is correct. And then we're just gonna say, oops, print certificate authority, server certificate chain, whatever, because we've been using the word chain. So okay, so there's there you go. Let's see if it works. There you go. Let's see if it works. Let's see. I think it's check cert as a default. Yeah, so now if we just say cargo run, it'll run check cert because we have, multiple binaries. So that's handy. Let's do this, cargo build. Hey, that worked. So cargo run. Oh my goodness, did that actually work? Yes, that actually worked. So there you go. Here is our, I don't know why I'm so surprised. The server certificate chain that's loaded, and the certificate authority certificate chain that's loaded. I mean, this gobbledygook makes no sense to me, but I just wanted to make sure that, it's working. So rustls is able to parse that stuff that we generated using CFSSL. That is a good win. So let's see. So we took care of the stuff in server rs. I think we have one more, this one. So now we're gonna repeat this whole journey for key ops, I'm assuming. So we can say pub mod key ops, because why not? So certificate ops is for, I guess, the certificates that the server needs and the certificates that the client needs. And then this is the ca.pem, which is the certificate authority. This is for the server. Or issued by the certificate authority, and this is certificate for CA issued by itself. That's exactly right. So this is what is happening here. And then key ops, we're going to have a similar kind of thing where there's going to be a function where we load the how do we put this, where we load this key data. But yeah, so key data from this, which file? This one, server-key.pem file. So yeah, so let's make that. We can say get, and it's a single key, I think. It's load key from pem data, because it is pem data. And let's see if this works. I don't think this is right. Yeah, I don't think this is right at all. Okay, so let's just struggle through this. So this is not correct. This is correct, but it's actually returning a vec of, it's a single key, and the single key is a private key dir. So let's import that. Okay, and then so now, okay, so we got the reader, we got the return keys. It returns. Okay, so I think it's gonna be a similar kind of thing, like read one transpose, but I think this is not right. This is going to be, it's not RSA key. It's gonna be PKCS1 key. Yeah, that's right. And the return keys push, and we're gonna push actually. So this PKCS1 key thing is a variant of basically, actually, oops, I think I did the wrong thing. I actually do want this, I just want this to be imported. Yeah, the rest actually, because I don't know, I find it a little bit easier to read like this. So the PKCS key is a variant, and what we want to do is we want to create a because there's multiple variants of this thing. So if you look at private key dir, it has PKCS8 format, PKCS1, and a whole bunch of other stuff. So in order to kind of like, so actually not a whole lot of other stuff, just PKCS1, PKCS8, and SEC1. And since we know it's pkcs1, what we will do is we will say private key dir pkcs1 key. So we're just saying, okay, go ahead and put the go look at the file, the PEM data, and then from the PEM data you can get like the first key and return it, or actually whatever keys you find. But because we've only generated the one key, I suspect we won't find more than one key. So let us encode that in another function, which gives a nice error message, because this isn't sort of an inner function. It is an inner function because it's not exposed externally. So this one, to make it a little bit easier to understand, I'm going to say server load single key, because that's the what file is it? It's the server key, and this will return. Oh, the pigeons are back. They're so cute. I wish I could turn my video so we can see all the pigeons. Very curious creatures. I sometimes put like little games for them to play outside, like a box or something. They're kind of like cats. Actually, I don't know that. I've never had a cat, so I have no idea. Or never hosted a cat. Let's see. All right, so niet result. What are we using? The private key dir. I think that's correct. Okay. What is the problem? Why is this unhappy? So niet result private key dir. What is your issue? Oh, right. Static. We had the same thing in the other one. And this is static because we're actually loading these things from bytes that are baked into the binary of this of the Rust target. When we do cargo build, we're actually baking them. If I had a ELF viewer, we could have opened up the target debug file and found it, but that's just distracting. Okay, so now what we want to do is something very similar. So we call certificate ops. So we can say something like this one. And a server-key.pem file, that's right, that's server-key.pem. So here we can say this is server-key.pem. That's exactly right. Fantastic comment, actually. So, okay, and then let's see, if it is empty, no server private keys found, and that is the correct name. And because I don't want to hard code the server-key.pem. It's redundant, I know, but it is what it is. And then let's see, if it is empty, well, so if it's not empty, why don't I just remove 0? What's the problem here? Yeah, something like that. So this just means that we just grab the first key or whatever it is out of this. And here we can say, I think, keys instead of 8. Yeah, or yeah, keys, and grab the first key. And then here, now we can remove our to-do, and we can just say, and print line. Let's hope this works. Server private key, and then we do cargo run. Hey, look at that. Server private key, pkcs1 private key, pkcs1 key dir, whatever, secret key elided. That's awesome. All right, so that worked. So now we have the very basics covered, which is we have the first binary in our cargo toml done, which is, I mean, we still haven't done anything in the sense that the client and the server isn't ready, but we have all the building blocks now to be able to create a TLS connection and a TLSAcceptor. And so all this work will pay off as soon as we go build these two next. The next step is to implement essentially some code that allows us to create a TLS connection. And there's two parts of a TLS connection. There's a TLS acceptor and a TLS connector, I think. Let me double check this. I think that, yeah, there's a TLS connector and there's a TLS acceptor. I think the TLS acceptor is on the server side and the TLS connector is on the client side. And I think the mental model for using this is that we create a TCP connection like normal. We take a IP address and a port, bind to it, and then we call TcpStream connect, and then that gives a TcpStream. And then instead of using that TcpStream, splitting it and getting the reader and writer half out of it using Tokio, I think what has to happen is that TcpStream then has to be enhanced or upgraded into a TLSstream. And I think that's what, yeah, that's roughly the mental model. So in order to do that, I think that's all in here. It's TLS, I think acceptor, no, TLSAcceptor. Yes, TLSAcceptor, and we have, I think, TLSConnector. It's not in here. Maybe it's TLS. Maybe I'm in the wrong crate. Interesting. Oh, let's try this. Doxa. Nope. TLS connector and TLS acceptor. Ah, it's in Tokio rustls. That makes more sense. So I was in the wrong crate. So this is where we're getting into finally the Tokio, because so far we've been in rustls. Now we're about to jump into Tokio rustls, and here we will find TCP connector. Actually, it says right here what to do. This is what I was saying. That's why I'd read it earlier. Is that, yeah? So most TLS implementations, it's essentially we start with a TcpStream, and then we use these certificates and keys on the client side and the server side to upgrade that connection to a TLSstream. Yep, that's exactly right. Okay, and here we will find TCP connector, and there it is. I'm sorry, TLS connector and TLSAcceptor. There it is. Boom. All right, fantastic. And again, this is the Tokio integration with rustls. So I think that was in cargo toml here. There it is. Actually, I already used the PEM file. That was just to, I think, be able to open up the certificates and keys in PEM file format. Wonder what this is saying. rustls just got an update. No way. That's cool. Oops, that didn't work. That is definitely a bug in, what the heck is going on? 2319. And this one is 7.4. Yeah, this dependy, I'm using VS Code Insiders, because for my regular work I use the mainline, or whatever, the release version, and for videos I'm using this Insiders. So it's always an adventure sometimes with stuff like this. Okay, anyway, dependy is a good oh, now it's working, whatever. Okay, so let's get back to, here we go, TLSRS. So let's make a new module, and this one is actually going to be TLS ops. So we have key ops, we have certificate ops, and we have binary data. So this one is going to be more TLS ops. And the thinking here is that I'm starting with a TCP. I'm starting with TCP stream, and I'm going to upgrade it to a TLSstream. So this is upgrade TcpStream to TLSstream, something like that. What was the standard? I think it was Tokio. And TLSstream would be Tokio rustls? No? Yeah, there we go. Okay, so I think we have to choose whether we do the client side first or the server side. I'm going to do this client side because I think we just have to do like one thing, the ca.pem. That's the only file we have to load. So we can say try to create a client TLS connector. So this one is, and then I think the other one we'll call it an acceptor. Yeah. So this will return met result TLS connector, I think. Let's do this. Yep. And yeah, pretty sure this is right. rustls pem file. Okay, so try create client TLS connector. Okay, so here the first thing we should do is actually this brings us to because I started with the client side. On the client side, in order to load the certificate authorities certificate ca.pem, we have to create a root certificate store. And typically this root certificate store will be some publicly available store, like Mozilla has one, where we would then add our certificate authority because it's self-signed, so it's not verifiable using any public sources. But what I'm going to do instead is just create an empty root certificate store and then just put our ca.pem inside of it. So in order to do that, let's make another module. So we're going to say pubmod root certificate store operations. I know it seems a bit verbose to have so many different modules, but actually it really helps me organize this stuff because there's so many different moving parts and pieces. Let's see, try to create, let's see, client, I think we should call it client create root cert store. And we're not trying to create anything, we're just gonna create it. So let's put this up there. Okay. So, okay, so the root, oops, client, yeah, okay. So we have a root cert store, that's an empty one, and then we correctly load the ca.pem certificate chain, and then we can, let's see, we can say for cert, so we can say, oops, ca cert chain, and then we can add the certificate to it and into diagnostic. There we go. I think it was complaining because there was an ampersand there. I don't know why I put an ampersand there. So I think this is correct. The root certificate store, and then yeah, and then it's this. So this should just work. So actually, let me just do this in a variable. Yeah, there we go. So we basically look at we call this function we wrote earlier. We get the ca.pem out of it essentially, and then which is a vec of certificate dir, and then we iterate through each one and then just add them. And there should only be one, but yeah, this should work. So now we're going to use this function right away, and then using the root certificate store now we can, actually that's just the first step. So then we have to, because we're on the client side, this is client, so this is the client calls this function, and then there's going to be another server one that we write later, but I can put a to do here for that. To do, let's say create the server side. Actually, create this TLSAcceptor for the server. And yeah, okay. So let's see. Actually, this is unimplemented. We intend to implement it. Okay, so then there's another TLS thing that we have to do. This is because of the Tokio rustls. We need to create a client config. So there's actually client config for the where is it? Actually rustls is client config. Yeah. So for the TLSConnector, we need a client config. So what the heck is going on? Oh, here we go. I think rustls, we have client config. We have a client config and a server config. Actually, let me open this in a new tab. So this is, yeah, okay, perfect. So this is it's a builder that will allow us to basically put all the necessary files that have been converted to the appropriate structs into this one struct, which we can then use to create our TLS connector. So this is called a client config. So this, we will deal with this server config later, but right now we're on the client side, so we're going to do client config. So this one is just a builder, so we say client config builder, and then we say, why is this not working? Rustls client config. Oh, and then with root certificates, that's right. And and no client auth. That means that we're not expecting our client to present any kind of credentials or anything to authenticate. We just want anyone with the appropriate, who can do the handshake, the TLS handshake. We just want them to connect, because the client has the certificate authority PEM file, so we trust them implicitly, at least for this example. So then, in order to make a client config, we have to wrap this in an arc, and that is a requirement of the this API. This one. It's the rustls. This thing. Actually, where's the builder? There's the builder. Config builder documentation. It's in here somewhere. Where is this? No client auth. That's what we did here. And then, yeah. Okay. Oh, I think the arc requirement is not. Sorry, it's for TLSConnector, which is not this, which is this one. This one has a requirement of I think the where's this? The from inner arc client config. This is what I was talking about. So that's for the Tokio rustls TLS connector struct. Okay. Then there it is. So, and then we can just return that as from this function. So this will, I mean, we don't know how to use it, but the client calls this function to get a TLS connector that can be used to upgrade. That is exactly right. Fantastic documentation from Copilot. Let's see. Yep, there you go. I'm just merging the imports to make it a little easier to read this stuff. Tokio rustls, TLSConnector, and then, okay, cool. Very nice. So that, I mean, obviously we haven't called this function yet, but that part is working, so that's great. So now we can do the server side of this. We can say pub function try to create the server TLSAcceptor, and that's going to return a TLSAcceptor, which we can import. There we go. So essentially, we can say the server code calls this function to get a TLSAcceptor that can be used to upgrade a TcpStream to a this one. Actually, to be consistent, why don't we just do this? Because there we go. That way it's clear like what pack or what crates each one of these structs is coming from. Right, so here we'll actually need two files because for the server, well, okay, in the client we need to create a root certificate store and ca.pem. For the server we'll need server.pem and we'll need the private key. So yeah, those are the two. So we need the server certificate chain, and then we need the server private key. I think that's pretty much it. Server private key. Let's see, single. Let's call it private key. Yeah, because that goes and gets the load key from PEM. Okay, that's great. Actually, I wonder if we should get from PEM data. Maybe this is also just rename, basically put the word private key everywhere. Just so it's clear that these are private keys. Okay. Okay, so now for the server side, we have the certificate chain for the server itself, and then we have the server private key. Those are the two files that we need, and now we should be able to actually, let's see. Then we can say, actually we need a, what is this called? Server config. Yep, server config. And it's the same kind of thing. I think there's like a from trade implementation or something. So we say server config equals server config. It's the same thing. It's a builder. And I don't know why it keeps saying with safe defaults. That is not a thing. Must be like a really old version of this API. Had that with safe defaults, because all the Copilot auto completions, I don't know, they have that in them. Okay, so this returns the results, so we're going to do into diagnostic, and that will take care of that. I think, okay, let's see. So with no client authentication and with a single certificate, and the certificate, so this is server.pem, and that is server-key.pem. And then, okay, so now we have the server config. Fantastic. So now I think we do that same arc thing, and then we can say TLSAcceptor, and when I think we can just return that, and that's the end of that. That was pretty quick, actually. So here we have the TLS operations. So this, let's see if this works. Well, let's see if it compiles. Okay, excellent. So now, given that the TLS ops have been flushed out, the next step is to create the server RS and the client RS, and we're gonna have to build them both before we can test anything. So let's just start with a client RS. So before we create the client RS file, I think let's create because we're going to create a client and a server, let's make a new module, a new file. We're going to call this common IO, and we're just going to put like the reading and writing operations, or the functions between the client and the server will actually go in this common IO module. And then we can put stuff like what is the host and the port and stuff like that in here. So let's do that, and then we can make the client. So let's make a module for constant, and then here I think, let's see, we need a couple things. We need the host, which in our case is going to be simply localhost. Then we need port. It's just gonna be, actually no, it's just gonna be 16. We need 8080. And finally, we need a server name. And the server name thing is going to be, in this case, role.com. And where the server name comes from is actually here. It has to match these hosts, because there's this, see if I can find it. Where's server name? There it is. So in rustls PKI types, there's actually a enum called server name, and you can create it from either a domain name, DNS name, or a IP address. So it's either so as long as your string is formatted as a DNS address or as an IP address, it can be parsed into this server name enum. So, and the key thing to remember here is if you have a string here like foobar, then your server name can be foobar. So we can actually, these would be both valid here. If I could type localhost, so either of them will work, but I'll just put rebel for reasons. So here we go. So this is our let's say let's see, this one is, yeah, so this matches up with the certificate name, so this should work. Okay, so now I think we had the constants, constants created, and now let's start with our client RS. So in this file, let's get the address that we will use. Oops, I think this is going to be common IO constants. And this needs to be pulled in. And then this one will be, there you go. Okay, that was easy. And then because we'll need that server name thing, we can take care of that here as well. So we can say let server name is going to be actually, so rustls PKI type server, I'm just copying it from here, rustls PKI type server name, and this one, did I type that wrong? Oh, oops, there we go. rustls, I think it's try from, yeah. And then put a, and then basically this means that if let's see, if we don't have a server name, we simply cannot proceed. So where is, I don't know why I didn't this import. There we go. Okay. So we got our host name and port. That's the address. This is for the TcpStream, and this is going to be for the TLS connector. Connector is the client side. So one thing we also want to do is we need to register a Control-C handler. So we can say register Control-C handler, and then we can say something like Tokio spawn, and then async. And what we want here is we want to basically system std process exit 0, and we also want to print a message before we, no, actually, well, not press Control-C to exit, Control-C was pressed. Pressed, and then we can just say exiting. And if we want, we can be all fancy. We can say like println, so this one, we can make that red or something. So we can do something like this, and then we can put exiting, and this one we can say red and bold or whatever. And these are all cross-term styling things, styling functions. Okay, so now if somebody presses Control-C on the client side, it will simply exit this program. So now we're going to connect to the server as per usual. This connection is insecure. So then we say let stream equals Tokio net TcpStream connect, and we do attr ester, and then we will say await, and in case that has any issues, we just do that like this. And now we gotta make this an async function. And here's our TcpStream, and this is normal. I mean, this would be like whatever. And then at the end, there's like a to-do split TcpStream and perform read and write operations, something like this. Essentially, the bulk of like what this program does. But that's going to be very, very simplistic, because most of this program is just to basically get the TLS connection up and running. So the actual bytes that are going to be transmitted between the client and the server are going to be very much like a netcat. Like the client will write some bytes, the server will then print it out to standard out, the server will write some bytes, and the client will dump it to standard out, and that's pretty much it. And we're not going to block on standard in, because standard in, when you read from standard in, it's a blocking call, and the thread that makes that call is blocked, and there's no way to kill that thread. So essentially, it's very difficult to exit the program once that's happened. So unless you do like a standard process exit, so which we're doing for Control-C, but it's fine. This is more for like exceptional conditions, like if the user wants to exit the program, but I'm not going to block on standard in. Just makes it easier for the logic and the asynchrony to kind of play out. Because what happens is if you block on standard in, the Tokio runtime, it won't be able to shut down, because there is actually a thread that's running and it's not a task, it's a full-blown thread. And that's just the nature of standard in, and that's just the nature of threads in Rust. I think Java a long time ago tried to create an API to kill threads, and they deprecated it pretty quickly, because I think it was Java 1.3 that did that. There was a lot of issues with that. So that sidebar aside, let us continue with our TLS connection. Okay, so we have our TcpStream. That's great, yay. And then now let's do what we came here for. We're going to upgrade the connection to a secure one. So first thing we're going to do is we're going to make a TLSConnector thing, which we've already built. Then we're going to, we already have a server name, so that's wonderful. Now we're going to say, we're going to get a secure stream. So we're going to upgrade the insecure stream to a secure one by using the TLS connector and the server name and the insecure TcpStream. And that's essentially the secure stream. And the secure stream, we can split it and it exposes a read half and a write half, just like a regular or an insecure TcpStream. So our code is none the wiser. So here we say reader, writer, and we can just split tokio split secure stream. And that's pretty much it. So this, now we have a reader half and a writer half on the client side. And so the rest of it is going to be like actually doing some IO, and we'll worry about that later. So that's all the setup on the client side to create a secure stream, which is pretty cool. So this is encouraging. Let's do a cargo build. Actually, I can also do a cargo run client. Yeah, and it, what is it doing? Pressing Control C. I didn't press Control C. Oh, oops. This is not a very useful program because it literally exits. What I forgot to do was await for this thing. Kind of important. There we go. Now, so basically we spawn a task and it just waits around for us to press Control C, and if we do, then it does a system process exit. If we don't, nothing happens. This task will be dropped when this process exits. So let's try this again, and this should work. Perfect. Connection refused. Exactly. OS error, because nothing is on localhost 8080. Yay. So this we can say add client RS. Perfect. Okay, so now let's do server RS. So the server's, oh, what the, that's strange. The server RS is almost identical, except that the setup bits are different, because we need the server certificate and the server private key, not the certificate authority certificate. So here, we know we're going to need this, so we'll say net result unit type, and then here we can say, we know this is going to be async as well, so let's get that all set up. And we also know it's going to return OK, and this is going to be rebel. Excellent. Okay, so here we can say same thing. We're going to get the address. Oh, there we go. We get the address from the server side. I mean, we got the address, but this is for the server. And then here we are going to do that same Control C handler, exact same, only this one we need cross term. Oops. Then we're gonna create. Yep, connection is insecure. Actually, we're not gonna connect to the server. We're gonna set accept this server. So we're gonna do. Let's see, listener. We're gonna bind to the IP address on the port. Then we're going to let's say accept the connection. So when you accept the connection, this task will block. So keep that in mind. So we can say accept is blocking. So yep, and this second half is the IP address of the client, which we don't really care about, at least for this example. So okay, this is useful if you want to identify, like if we were going to accept more than one connection and you wanted to identify, tell one connection apart from the other, then this would be a good handle to keep around. But in this case, we're not even looping on the. I mean, it's just going to be so simple. This is like one connection, one client, one connection, one server. Okay, so this is all great. This is our old school stuff. Nothing interesting here. Let's make it interesting. So we're going to make an acceptor. We're going to make a secure stream, which essentially takes the TLSAcceptor that we make and upgrades it. Upgrades the TcpStream into a secure stream, and then we can extract the reader and writer from it. And that's literally it. I mean, I know things went pretty fast at the tail end of it. And then this actually we already split the. So this is more like perform read-write operations. This is the only thing that's left, and here we can say perform read-write operations. So so now let's run this and then see what happens. We say we can run the client. It just doesn't do anything. Look at that. The server is waiting for a connection. So this is fantastic. So this so far it's working. I mean, obviously we haven't implemented the read and write, but let's do this rs. But so far the setup is complete on the client side and the setup is complete on the server side for TLS. Now we're going to connect the two, but this is going to be pretty straightforward. It's like there isn't a whole lot that's going to happen here. So this we're going to do something like that. So in common IO, we're going to make a new function called read write, and we're just going to, believe it or not, call the same function on both the client and the server. And in this read write, what we're going to do is, let me see. So let's bring in a bunch of these imports. Let's see. Async read. We're going to bring in async read and async write. Okay, and so what this is going to do is that we're going to essentially connect the client and the server together. So when the client writes some bytes, the server will read it and display it to standard out. When the server writes some bytes, the client will read it and display it to standard out. So that's the setup. And in order to do that, we can either ask the user to type in some strings on the keyboard and hit enter, but that will require us to block on standard in, which is something I don't want to do. If you can use Tokio IO standard in, that's a thing, but that's mostly for programmatic, like when you're piping stuff into a process. Tokio IO standard in can be used, but for interactive processes like what we're doing, it's discouraged because it's gonna tie up a thread, and when we exit this function, or when one half of the reader half or writer half terminates, that thread is going to stick around basically until the user hits enter. This process is essentially hung up, and we don't want that. So fortunately, in the Rebel repos, there is a really awesome crate. Let's see, there's a really awesome crate called Rebel Test Fixtures, I think. Yeah, Rebel Test Fixtures. And here, there's a really good, let's see, gen input stream, I think. Gen input stream with delay. This thing is awesome. Essentially, it's just a, I can create an input stream to mimic user input, essentially. So let's see. Okay, so this function actually generates an input stream, and what we're doing here is simply actually, let me bring these imports in so these reds go away. Okay, so here all we did was that we're saying that create a new input stream, and that input stream is going to essentially provide one character line feed, two character line feed, three character line feed, and then just line feed, and it's going to do this with a delay of 500 milliseconds. So it kind of looks like one is typed, then there's a delay, then two is typed, then there's a delay, three is typed, and so on. And so this is what we're going to show, what we're going to see between the client and the server, that they're going to say 1, 2, 3 with a delay of 500 milliseconds. So then that's the sort of the fake user input. So here now we need to just provide standard out so that the stuff can be written to. And then here we're going to do something really cool. It's the Tokio copy function, and we're going to basically say grab whatever's in the reader and just dump it to standard out. And then that's one branch, and then so this is going to copy everything that's in reader, and as whenever it it finishes reading from the reader, it'll dump it to standard out up until there's an end of file or the connection gets terminated. So that's essentially it. Here we could have done something like this, except that input stream doesn't implement the async write or read or whatever. So instead of doing this, there's a way around. I mean, there's a simple way to do this, which is I'm going to make another. Actually, I'm going to take care of this real quick. Rebel. Okay. So I'm going to make. I think these are a bunch of traits that need to be pulled in. What is going on? Where? Let me double check these imports actually. I don't think it brought in the imports correctly. Let's see. Yeah, there we go. Okay. So essentially what this function does is that it reads from this input stream. It's an async function. And it takes the input stream as an argument along with the writer. And the writer is the end that writes to the other side of to the other host. It's the thing that's writing to the other host. Because client and server are both using the same function. So it just basically just gets the next whatever it is, the next struct. I think these are just. I think this generator vec is it's just a vec of strings. So it just grabs the next string, then it writes that string to the other end of the socket, and then it flushes it. So essentially, this is reading from the input stream one item at a time, and then writing it over the socket. So that's essentially achieving the same outcome. It's just that it's written. We can't use Tokio copy because this thing doesn't implement. I think async read or something. Okay, so let's see. This works. Cargo build. So okay. So now let us do this. What folder are we in? So let's see if we can cargo run. Bin, I think, server. Let's see if we can say client. So we're running the server, by the way. This server is running, and I'm going to launch the client. Oh my goodness, check this out. 1, 2, 3. So that was it. That was the whole demo. And if I hit Control C, notice that Control C pressed, so it's exiting. And so, like for example, if I start the server. And and then I start the client, and then I go back to the server and kill it. It'll abort the the other process as well, which is, you know, working as expected. So all that setup was the bulk of this journey has been to create these JSON files, which allowed us to generate these certificates, and then we brought them into Rust. We wrote a program to check the certificates, and then set up a TLS connection between the client and the server. And it was actually trivial to write the client and the server. You think about it, the bulk of the work was everything before that. So yeah, with that, that's the end of the stream. Please like and subscribe if you're into these kinds of videos. I have some really interesting ones coming up. I'm going to do a lot of hardware reviews. I have a bunch of those queued up, and a bunch of developer productivity videos, along with a whole bunch of other interesting things that are programming Rust related. And if you haven't already, please check out developerlife.com. I will be taking the README from this repo, and it's because it's pretty big, and I think it's pretty well written. It's going to be migrated to Developer Life, so if you haven't already, you know, please let me put this in a different screen. Let's see. If you haven't already, sign up for our newsletter. I don't really send out that many, maybe once a month or something. And then we have a Discord, because I have comments disabled on YouTube, but if you join the Discord, it's not much of a lively community. It's more for Q&A at this point anyway. So if you have any questions about this specific video, if you want to give any comments on a particular video, requests for future videos, or if you want to discuss something that, you know, you have questions around that are in one of these videos, you know, feel free to join the Discord and drop a line. The reason I disable YouTube videos is because there's no code of conduct or anything on YouTube comments, but on Discord there is, so that's one of the reasons. So yeah, I think the US, it's going to be Thanksgiving soon, so for all of you in the US, happy Thanksgiving in advance, and you'll see me in the next one. Take care.